Hi, myself Dr.P.Shivaranjani, Academic Coordinator, Department of Graphics and Creative Design and Data Analytics. So today we'll discuss about Boolean algebra in logical gates. Boolean algebra is the category of algebra in which the variable values or truth value, that is true or false, ordinarily denoted by ones and zeros respectively. It need to analyze and simplify the digital circuit or digital gates. It is also called as a binary algebra or logical algebra. It has been the fundamental in the development of digital electronics, and it is all the modern programming language. It is also used in the set of theory and statistics. The important apparatus performed to the Boolean algebra are conjunctions, disjunctives, and negations. The rules in Boolean algebra: the only two values, for one for high and 0 for low, are possible for the variables used in Boolean algebra. The over bar is used to represent the complement variable. So the complement of the variable C is represented as dot. The plus operator is used for representing the ORing of variables. The dot operator is used for representing ANDing of the variables. Boolean algebra, we have 9 different types of Boolean rules. One is called as identity law, null law, important law, inverse law, commutative law, associative law, distributive law, observation law, and De Morgan's law. It can be represented in either the form of AND form or OR form. In the form of AND form, it can be represented as 1A equal to A, and in OR form it can be represented as 0 plus A equal to A, and in null form it can be represented in the form of AND form 0 of A equal to 0, whereas in the case of OR form 1 plus A equal to 1. Important law, A equal to A, that is A dot A equal to A, whereas in the case of ORing form A plus A equal to A. In inverse law, A dot A inverse is equal to 0, whereas in ORing form A equal to A inverse equal to 1. Cumulative law, AB equal to BA, whereas in the case of ORing form A plus A bar equal to 1. In cumulative law, AB equal to BA, whereas in the case of ORing form A plus B equal to B plus A. And the associative law, which state for AND form, is A of B into C is equal to A of dot B dot C, whereas in the case of OR form A plus B plus C equal to A plus B plus C. In the case of distributive law, A plus B C equal to A plus B into A plus C in the case of AND form, and in the case of OR form A into B plus C equal to AB plus AC. In the case of observation law, A into A plus B equal to A, where in this case of ORing form A plus AB equal to AB. De Morgan's theorem, this is the very important theorem. We'll discuss the how to derive the De Morgan's theorem. A dot B inverse is equal to A inverse plus B inverse, and in the case of R form A plus B inverse is equal to A inverse dot B inverse. The De Morgan's first law, there are two different types of De Morgan's law. One is called as the first law, and the second one is called the second law. In the case of first law, A dot B inverse is equal to A inverse plus B inverse. The first law states the complement of the product of the variable is equal to the sum of their individual complements of the variable. The truth table shows the verifications of De Morgan's first law is given in the table. So here we have taken 2 to the power of n simplification, that is we'll have 4 combinations, that is for 2 to the power of n we have 2 to the power of 2, that is 4 possible combinations will be obtained. So for a dash we'll have the inverse of a, and for b dash we'll have the inverse of b. For example, b, if the value of b is 0, the value of b inverse is equal to 1, and if the value of 1 is equal to if the value of b is equal to 1, then the value of b inverse will be 0. And the De Morgan's law, in the first law, a dot b equal to, we'll have the inverse of the, that is the complement, that is ANDing of a and b, that is if both the values are true, then the value of a dot b equal to will be 1. So here the inverse of a dot b will be if both the cases are 1, then it will have the value of 0, and in other cases it will have the value as 0, that is 1. And a plus b, that is a dash plus b, will have the reverse of a dot b inverse. So this is the first theorem, and the second theorem is a plus b inverse is equal to a inverse dot b inverse. The second law states the complements of the sum of variables equal to the product of their individual complement of the variables. The truth table shows the proof of the De Morgan's second law. Here we have taken a and b, the inverse of a dash and b dash has been given as, if the value of a is 0, then the value of a dash is 1, and if the value of b is equal to 0, then the inverse of b dash is equal to 1. So according to that, a plus b inverse will be have the value of 1 0 0 0, and a inverse dot b inverse will have the value of 1 0 0 0 for the case of 2 combination, that is 2 to the power of 4 for the combinations. Here we'll have some example to simplify your Boolean expression. So if you have to consider the Boolean expression c plus b bar c, so we have given that expression according to the De Morgan's theorem. We can write the above expression as c plus b bar plus c bar. From the cumulative law, we can derive that c plus c bar plus b. From the complement law, c plus b c bar will have the value of 1 plus b equal to 1. Therefore, c plus b is equal to 1. So we'll taking another example, that is we have given an Boolean expression that a into b plus d. So for that we have drawn a truth table, and after that we have the corresponding deviations for the Boolean expression. So here are all the some of the assessment questions. So what is meant by Boolean algebra? What are the some of the applications of Boolean algebra? And what are the 3 main Boolean operations? What are the values 0 represents true or false? What are the 6 important basic laws of Boolean algebra? So these are the some of the assessment answer for the questions. So we'll see you on the next session. Thank you for your patient listening. Thank you.